Hi, Amai, good morning. Can you hear me? Can you hear me? Amai? Okay, good. Today it's going to be a very new lesson, right? Unfortunately, for some reason, none of my regular students even not presenting in the today's class because I know the reasons. All of them are like kind of match enthusiasts, and there is a match running on with Sri Lanka and New Zealand, and Sri Lanka is just about to win. I don't know what happened because it's Auckland and a very small ground. Whatever it could happen, but in Sinhalese we used to say like Ethiopiaවට පාන් දානවා වගේ වැඩක් නෙවෙයි ඉඳලා හිටලා මැච් එකක් දිනන එක. So unfortunately it was a very bad day. I started this seminar and they have hammered like 196 runs and everybody sticks to. And my regular students also texted me and say, "Sir, ටිකක් පරක් වෙනවා පොඩ්ඩක් විනාඩි 15ක් 10ක් දෙන්නකෝ." Like that I waited and okay. But in my case, I'm not waiting for anybody. So let's start the lesson. Right? If they have missed this one, then they can just log into the class. Sorry, they will watch the video later. Okay. Thermodynamics. In terms of the thermal physics, basically called as thermal physics, right? What is it? It consists of some basic parts, right? So heat, we just can simply say heat, but heat is just a primary word, but we have to say like what? Thermal physics. In thermal physics, there are many parts. First one we have to learn today is, what is it? Thermometry. Thermometry. Right. Thermometry. After thermometry, there is another part. That is what? Thermal expansion. Thermal expansion. The next one is the thermal expansion part. Thermal expansion. Right. Thermometry is kind of familiar, but we haven't done any calculations so far in our O-level life. This is the first time you are going to do some calculations according to thermometry. Like, so we used to take the readings of thermometer since grade 4, I think. Like 100 Celsius, 50 Celsius, 30 Celsius in body temperature. It's somewhere like 35, I can't remember, 37, whatever range. But the calculations, no, nothing. We don't know even the mechanism of a thermometer. We just know there is a line which drives up and down, and there are digital thermometers. In the digital thermometers, there are certain numbers. Those are the only things we used to know. But in this thermal physics, thermometry, we have to do like a design, what? To know the basic theory of designing a thermometer and how to apply it. And in this case, the thermal expansion matter. So expansion is the next lesson. I'm not going to explain much about that, just to give you a very simple clue. And you know that there is a gap between what? Two railway tracks in the same track. In new rails, they don't join these two together like this. Because of the expansion, they have to keep like 1 inch gap. And in terms of cables, wire cables, you see in the daytime it hangs like this. During the night time, it is going to get tightened like this way. So this is also due to thermal expansion. I will explain. You know this factor even since grade 5, 6, but you didn't do any calculation. In A level, you are going to do calculations with some theory And after doing thermal expansion, you will definitely understand the mechanism of what? Thermometer, likes of the mercury thermometer as well as alcohol thermometer. Right. Thermal expansion is the very next part. After that, there is a certain mix up with the syllabus. According to different teachers, different perspective, they do different order. But in my order, I'm going to go with calorimetry, something called calorimetry. This part only you have done so far. In your O-level even, you have done something like this in your O-level life. Calorimetry is the only part you have touched so far with mathematical approach. Can you remember? A very simple equation is there. What is that? O-level. Very simple equation. That's the equation. It's going to be playing the same game here, but with some different approach. That is what? Q equals to MC delta theta is the equation, right? Q equals to MC delta theta. But this part also, my plan is not to teach you today. I'm just telling you how to deal with. That's it. Okay. This one is going to be the third most lesson. And after that, there are many lessons. So in my order, I would like to go with thermal exchanges. Thermal exchange. This one, even you have to know, you happen to know, there are three ways of exchange of temperature in O-level knowledge. I'm not talking about your A-level knowledge, O-level. Can you tell me the basic three ways of exchanging temperature? Heat energy. It may raise or drop of an object, temperature of an object by means of thermal exchange. There are three ways. Let's see whether you can remember. Yes, conduction, convection, and radiation. My aim is to teach this part as the fourth one. Actually, some teaching methods, they teach in the last part as the thermal exchange. But these two have a real good chemistry, really big chemistry. So I don't want to teach these two as two different ends, because once we done this part, it's really easier to move to here the thermal exchange like conduction part, because the conduction part has the same impact likes of calorimetry. Okay. In the next case, there is another part. What is it? Gas laws. Okay. Are you chemistry student or IT students? Because if you are in IT stream, you don't know about much about gas laws. I'm pretty sure in chemistry, you might have already learned about the gas laws so far. Are you chemistry students or IT students? If you are an IT student, you have to wait for me to teach in physics, me or any other physics teacher to teach. Have you done these gas laws? Boyle law, Charles law, and universal gas law. And there are some other things we are not in touch in the chemistry. In chemistry perspective and physics perspective, in chemistry perspective, they just superficially look at these ones. But in physics perspective, we have to deal with something called thermodynamics as well, in link with the gas laws. Okay, after gas law theory, there is a thing in these days we are extremely experiencing that as a chaos. What is it? That is known as humidity. The relative humidity is really high in these days. That's why there is a kind of unbearable heat. For me, I don't know about you, but it's really unbearable. If you are living in somewhere like Norelia, you might feel some coldness, but in other areas, everybody experience really high heat. It is not due to the high sunlight falling. It's badly due to humidity factor. We don't call it like humidity. In here, physics, we used to call it like hygrometry. 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 And the last one, what is the last chapter? That thing I taught, thermodynamics. Thermodynamics is a really beautiful subject. And if you are really having any interest in learning something like motor mechanics or engine designing, even aeroplane and everything, you will have to deal with but thermodynamics. There is one of the guy I used to know who used to do like tech stream. That guy just came to me in like 3 weeks earlier. He asked me, he's in some university now, technical university, like NIDM or somewhere, I don't know. He just came to me and asked. He showed me the stuff. Then I got surprised. It's all about thermodynamics because he does higher diploma or degree in motor mechanics. In that one, there was a really big scale of what thermodynamics in there. They haven't touched in here A level because why? That is technical subject. Tech, you call techno. But they have to learn that thing in university level. But fortunately for you, you learn the basics of thermodynamics in A level, and after that, you are going to step into the next level, like in the university or somewhere else. Okay, guys, have a look at it. Last one is what? It is called thermodynamics. Right. These are the 7 lessons we have to do under thermal physics. Right. I have to tell you one really important point here. There are 2 different types of teachers. One is having high extreme of teaching the stuff really slowly. They take longer time and only do like 1, 3, 4 complete subjects. And after that, exam is just around the corner. They just distribute some tunes and just do random stuff and send you to the exam. There are some other guys, they used to do the syllabus really fast, extremely fast, and finish it and nothing in your head. But I'm not in those 2 extremes. I'm a medium level guy. That means doing at the right phase. Right phase means we don't have much time to do like bullshit and just talk like nonsense and political stuff. Nothing. So focusing on the lesson, today it's going to be the thermometry. In thermometry part, my aim is to finish it within today. Thermometry, I'm going to finish because thermometry is not really important one. You rarely get a structure in many years, but you have a great deal of chance because the thermometry question hasn't been come for very many millions of years now. So it might be your chance, but MCQs, you have a slight chance of getting 1 or maximum of 2 MCQs from thermometry. But the next lesson, thermal expansion, is a really important one, and the rest of the 6 units are extremely important. So today, my plan is to teach you what is heat, what is temperature, and what about what? Thermal laws, the first law of, zeroth law of thermodynamics. You might have been in some other classes already, I'm pretty sure. Can you tell me what is the zeroth law of thermodynamics if you know? Today I'm going to teach. to test your knowledge, whether you know something or not. If you know, just tell me no. If you don't know, no, I don't know. That's it. Let's move on. Okay. It seems to me that none of you are really aware of that. By the way, in which group you are joining to this one? Because I didn't share the PDF yet of this lesson. ඔයාලට මේ lesson එකේ PDF එක හම්බුන්නේ නැහැ නේ? Guys, I think you didn't get the PDF of this lesson yet. So in what group you are? Because you are coming from different groups. Or will you drop a personal message to me, because I have to share you the, no, I will share you the PDF to all the groups. Let's start the lesson. Just give me 2 minutes. Until then, just stay there. I will just share you the PDF of this lesson, tute of this lesson to all the groups. Just give me 1 minute. Okay, guys. I share the PDF to all the groups, and not to the one that's called the physics seminar, only the admin can send. So I sent to the admin, and she will share it to the group. And to Malina, I think I just directly forwarded it to you. Okay, guys. So it's about to start thermodynamics. Sorry, not thermodynamics. I was last talking about thermodynamics. The thermometry. I use a certain different techniques that's going to help you this in really much in like understanding this, because in this physical world I have a limitation to use it, because this is all about vibrations of molecules, right? Temperature and heat is nothing all apart from vibration of molecules. I can't show the vibration of any molecule. Can I vibrate this one? If I draw this one as a molecule or a particle, so can I just vibrate this one in this board? And so you know. So you will see how I am going to vibrate all the molecules and particles and show the absorption and release of energy within just 1 minute. I use a virtual board. In the virtual board, I can do all the magic. Just stay there for 1 minute, then you will see how I am going to use that. Okay, guys? So just give me a 1 minute. Can you just hear me? So this is what I was talking about. This is the board that I'm sharing. So in this one, I can use some multiple things like interface and apply and all the things. And so it's going to be really helpful, and you will get immediately used to this one. So as I told you, I have to deal with what? Molecular vibrations. So this is just a demonstration. Nah? So I can hold one molecule and show you the amount of vibration according to the variation of temperature. You will see when the temperature raises, the vibration increase like violently. When temperature drops,
it drops. So all of these can only be done in this board. I can't show the variation in real physical board. Okay, you might understand this one really sooner. Okay, guys. So let's go back to the tute that I provided you today. So this is what the tute I shared you. Did you receive this tute to you? Please let me know if you didn't get the tute. Lamai, if you didn't get this tute, just drop me a message to my WhatsApp and get it, because you are just joining from different groups and I don't know where you are coming from even. And unfortunately, my regular students are not even today in the meeting. The problem is in the day because the cricket match. Okay. Okay, guys. So if you didn't get the tute, just let me know, because I shared you the tute to you. This is what the tute, temperature thingy, how to know temperature, thermal equilibrium, and zero laws of the thermodynamics, and some thermometric properties, and how to build a thermometer. And those are the stuff we are just going to deal with in today, and learn how to make all of this, right? And there are many things like triple point of water and some calculations, all have to be done within today. And I will show you this thing today as a practical one, this thermocouple thing, because I have a kind of thermocouple. Those tech people might know what is this. Those who are tech people might already know what is this one. If you are really into computer science, you know what is a thermocouple, because there is a device called what? Peltier cooler. We use a thing called Peltier cooler in computers to cool down the computers, right? Okay, shall we move on to the first topic? First topic in here. Write a big topic. Temperature. Temperature. Okay, temperature. Okay, what is temperature, by the way? We know one thing, only one, there is only one sensory organ in our body which helps us to measure temperature. So sense temperature, not to measure actually, sense. Only to sense. But to measure, there is nothing with us. Right? Only one organ, that is our skin. That is what? Our skin. Using our skin, we can only feel it. We say, like, it's too cold, it's too cool, or it's too hot. Cool or hot. We can only say whether it is cool or whether it is hot. But we can't exactly say what. Imagine you are just putting your hand into something like 1025 degrees Celsius. Your hand instantly melt, right? And it will be powder. Can you say, oh my God, it's too hot, it's 1025 degrees Celsius? Can you say? No, because it can only say it's too hot. You don't even feel it, because why? Your hand get benumb. And the next thing is, you drop your hand to a certain liquid which is kept at like -100. Okay, your entire hand get frozen, right? When you try to bend your fingers by force, this one will get detached. It will get broken. This condition we used to know as frostbite. But we can't say, oh my God, I got my hands frozen. It's -100 degrees Celsius. Can you say that? You might ask, oh, how come a liquid be this below? There are different liquids, not only water. Water is the one, or it gets what is it called, frozen at 0 degree Celsius. But if you add some impurity, even water becomes like -15, -20 to become frozen. So it's a different process. According to the composition, water is also behaved very differently, right? So now, if you drop, can you say the amount of temperature in there? -100? It is -100. No, you would only say it's too cool, it's too hot, it's moderately hot, it's moderately cold, it's the optimum temperature. That's why you can say, we can't say like exact values. You need something called what, thermometers to measure. Okay, now write it like this way. Temperature is a sensation of amount of heat. Temperature is a sensation of amount of heat presence within an object. It the only the human skin, only the human skin is capable of sensing this, sensing this, but without any numerical perception. Human skin is the only organ to sense this, but without any numerical perception. Now write the definition of temperature. When you are writing a definition, please use this type of specific symbol. I normally use a hashtag or a $sign because I never use star sign to imply a definition, because why? Star signs are only for important points. Remember that definitions are extremely important in A-level physics. All the physics is based on the definitions. Now write the exact definition. I will write it even on the stuff. A measure of the, write it, a measure of the, a measure of the average kinetic energy, average kinetic energy of the particles, in an object. This is what called temperature in the definition. What is it? The measure of the average kinetic energy of the particles in an object. Okay, I told you it is all about what? Movement of the particle. Okay, when a particle is moving, there is a kinetic energy. We used to know one thing. Let me explain you. If a body got mass of m and moving at below a certain velocity of v, this happened to gain kind of kinetic energy that is equals to half mv square. Isn't this right? Understand? So the energy is half mv square. This is what we used to know. So average kinetic energy, because one particle might travel around, imagine it moves around what, 200 meters per second. Another one only 50 meters per second. But this one has a mass of m, but this one has a mass of 4m, right? And different amounts of different velocities, different masses. So the kinetic energy is very different in each particle. So what is that? That's why we take what? Average kinetic energy of all the particles. The measure of the average kinetic energy of the particles in an object is known as the temperature. Okay. Now, after the definition of temperature, we have to go for the definition of heat. right? Heat. Temperature is measured in different manner, but here we are just about to learn about heat. What is heat? What type of quantity is heat? What type of parameter is heat? One thing you have to know, heat is a kind of energy so measured in joules. Copy this as a topic, subheading. Heat is a what? Measure of energy. Okay. Copy the topic. So what is heat? Heat and temperature. We always wind up with this topic because we think heat and temperature are two exactly same. No, my dear, it's not same, right? It is kind of what? Energy, right? Heat is temperature is a kind of sensation of what? Average kinetic energy, right? Temperature is like a feeling, heat is like a energy, right? Write this in a new line. The definition, directly go for the definition. A form of energy, a form of energy transferred from, form of energy transferred from, definition na, the form of energy transferred from one body to another, one body to another as the result of difference in temperature, difference in temperature. Okay, there to transfer this heat, there should be something called heat difference. Okay, as an example, there is a one body here as A. There is another body. Let me take it from shapes. Another body there. But this one looks really small compared to the other. But there is a one factor which is high. T1 temperature of this one, but this one has a temperature of T2. And I would say T1 is larger than of T2. Okay. What can happen now according to our definition, previous definition? This one is capable of transferring heat energy to the other one, right? This one is capable of transfer. This is what? Transfer of heat. As I told you, there are three ways of transferring this heat. You know, since you're O level, what is it? This is not the heat transfer lesson today. Actually, we are just learning something else today. Thermometry only. Heat transfer I will teach in the transfer of heat lesson. So there are three ways. What are the three ways? Conduction, I'm just reminding you only. There are three ways. One is conduction. Other one is convection. The last one is what? Radiation. Radiation. But the radiation is not in this lesson. These two are to be taught in under heat and thermodynamic lesson. Thermal physics part. But this all three belongs to thermal physics, but radiation is the only one we learn under another lesson called matter and radiation, the last lesson in the lesson of matter and radiation. In that one only we learn this one, as a whole new session, Boltzmann law. Right, guys? But today I'm not going to teach any of these. I just reminded you, any of these mean it can be convection, it can be conduction or radiation somehow. If these are thermally in contact, what? Thermally. What is the meaning of thermally in contact? Thermally in contact means you don't want to contact A and B like this, right? Thermally in contact, right? Imagine for you guys, you might have a long distance relationship. This is all A-level class. A-level class means no children are there, all like well over 18 now. So it's no harm to talk about this. Right? LDR in physics, something else, but in relationships, LDR, long distance relationship. You have no physical contact. At least you can't just say high five with them. But you have a good, strong relationship. How? Via mobile and WhatsApp and other Discord and many other devices. Even in old days, they had LDR using just like letters. In Hindi films, you might have seen that a pigeon is carrying those letters like मेरे चिटिया उनको मिला दो කියලා අරු ගැතේ යවනවා. So somehow LDR like that, there is an LDR technique in A and B. Why? Object A and B by means of what? Radiation energy. Thermal contact means it doesn't always need to be in physically contacted like this, right? It is like sharing your feeling through WhatsApp. Radiation is something like that. Even our feelings are going under radiation. What is that type of radiation we used to share our feelings with the other one? It's also in the electromagnetic spectrum. Microwaves. We use microwaves in mobile devices. That is why you feel your head becomes really hot after having a really long call with somebody. Because why? Microwaves has the exact vibration capacity of what? Natural vibration of water. So our body has, I don't know the biological factors too much. It's like 90% of water, no? If my inference is right. So somewhere like this, really high percentage, I can't remember. It is like 76 or 90, but really high percentage of water there. So this water gets vibrated. And today I will teach how the heat generates. So as it oscillates, as these water molecules oscillate in the head, in this affected area, feels like you are in a heck. It's affected after you have long call with your anybody, right? So somehow thermal contact means you don't want to physically in contact only in conduction. Even in convection, you don't want to hold it physically. These two are LDR. This is a short distance, but this one is a long distance, very long distance. Why? We get the warmth from sun. It is some millions of 149 million kilometers long, million kilometers long distance from Earth to the sun. But we still get the warmth through what? Radiation. Can you understand the transfer of heat now? Still, I didn't teach you how does this link with the temperature and heat transfer with the molecular kinetic energy. But I'm just explaining you yet with respect to the what heat and how does it transfer. Should you understand the basics? Without understanding the concept of heat transfer, entire heat lesson is going to be a heck. Loka vinashayak වෙනවා. If you don't understand the heat transfer well and how the heat move from one body to another, Okay. Now write. Don't write these things. So now write. Heat transfer occur always from an object which has higher molecular kinetic energy. Higher molecular kinetic energy. Oh, what is that molecular kinetic energy, Lamai? Again, one more time. I will draw few random molecules. Molecule or particle. Just write particle. It can be any other particle rather than molecule. So particle kinetic energy. In terms of what? Particle kinetic energy. This one also has its own particles. I will show you the type of vibration in that. Okay. I'm going to enlarge and only mark few particles of this one. Few particles of this one. And also 3 particles from this one. And I mark this one as a high temperature T1 and the part object B as T2. As per my inferences, T1 is greater than of T2. Okay, T1 is greater than of T. Oh shit, no. T1 is greater than of what? T2. T1 is greater than of T2. Right. Now, how about the particle vibration thingy? How about this particle vibration thingy? Have to know one thing. In terms of the particle vibration, this one has a high temperature, as I told you. So this may vibrate like this. Really madly vibrate. I will enlarge this surface and you will see clearly. See, vibration is with a very wide range. This particle also has the same type of vibration. Random vibration increase as you increase the temperature. This one, very wide range. But in this one, your vibration is really limited. Very small range. Vibration is very unnoticeable. Really like unnoticeable. So these particles has an ability to capture heat energy from anything. It can be from a radiation, it can be due to friction, it can be due to some heating element. Whatever the way, it doesn't matter as long as it provides. These particles are capable of capturing heat and stored very temporarily in forms of what? Vibration. Actually, anybody is not capable of retaining heat as heat itself, right? No object in the world is designed to retain heat itself as heat, but the bodies can store heat temporarily in forms of what? Kinetic energy of the body. Particles of the kinetic energy of the body. සමහර ඕක kinetic කියලා කියනවා. ඇත්ත වචනේ ඕක හරියට ප්‍රොනවුන්ස් වෙන්නේ kinetic. දැන් බලයි මොකද්ද මේ kinetic කියන්නේ කියලා. Right. Can you understand? It's all about what? Vibration. Okay. Now what happens? These particles are capable of transferring heat from highly heated object to the other. Transfer. Okay. Now copy this diagram. Copy this diagram. So it would result something like this, but okay, wait. We will have to draw something else. So the vicinity of the vibration is really high in this one. See, really high vibration capacity. In this one, the vibration is very limited. See, very small region is the vibration capacity. See, this one has a very long vibration capacity because of this high temperature. It has a really high average kinetic energy. Average kinetic energy is determined by the vicinity of the oscillation. Now have a good look at after this process, something really miraculous going to happen. What is that miraculous thing? The oscillation is going to get equal because after his transfer, it has to come to a common temperature, right? The temperature is really common now. This one has the same temperature and B gets the same temperature. A and B comes to some equilibrium. What about now? TA is equals to TB. This is called equilibrium. Copy this. I will teach you each of these terms separately. Don't worry. Copy this diagram quickly. Ramai, I want to talk to you individually whether you can speak up with microphone if your microphones and stuff working, and if you are not really high a profile introvert, can you speak up? Just like to teach you. Malina Methman might be a Mahanama College boy, no? Then and his profile, he seems to be like a cricketer. Then you might not be an introvert. Hello, Malina. Malina, can you speak up? He dropped a message for some reason. Might be a really big profile introvert. Mic broken. Okay. He said his mic broken. Everybody's Hamdi Jaufer. Are you a boy or a girl? I can't just guess it from your name. Hamdi Jaufer. He's not speaking. Even Devutilina Sajahan. Hello? Oh my God. Oh, okay. Can you understand what I said here?
Yes, sir.
Okay. You can understand what I said. Okay, Hamdi Jaufer, can you speak up or just text whether you understood this so far? Hamdi Jaufer. Okay, and Niranjana, the other one. And Niranjana, the other one. Can you speak up? Seems to be I'm kind of teaching to kind of high profile introverts now. Okay, no problem. Okay, copy these all the diagrams. So see, this one has a very low vibration capacity. This one has a very big vibration capacity, but this one has a low vibration. Now all the particles vibrate and oscillate in a what? Proper oscillation region with an equal oscillation. The kinetic energy in both the cases are exactly equal now. So we used to call this one as TA and the other one as TB. TA and TB. Okay, this is what happens in transfer of heat. Now write this in a new line. The object A has a high kinetic energy in the particles. Object A has really high kinetic energy of particles, which means it has a higher temperature than the object B due to lower temperature of the particle B due to low vibration. Lower temperature of the particle B due to low vibration of particles. Low vibrations of particles in B. Lower vibration in particle B. Hello, Dinanga. Can you speak up? Dinanga. Hello. Come lamai. Dinanga. Okay. Even Z is kind of introvert, I think. Okay, doesn't matter. Now in this one, have a good look at. Now write the heat energy can be transferred from an object heat energy can be transferred from an object having high temperature to low temperature. Now write these 2 points with star signs. Now to the previous diagram. Go to the previous diagram. We drew and write with the star sign. As the temperature drops from an object, molecular vibration drops as well. As the temperature drops an object, molecular vibration also drops. The temperature drops from an object. What happens? Particle vibration drops. Particle vibration drops. Right. Include this detail to the previous diagram we just drew. And this one, it is the opposite case. You have to write your own note for this part. What happens? I will tell you for one last time, but in a faster way that you can't write. That is what? As the heat energy absorbed by an object, the particle vibration increases. Now write that in your own words to this part. I'm not writing because this one is supposed to be an A-level class, advanced level. Done? Done including? I think it's enough, right? We learned more about the molecular transfer of energy. Now write this as a very important point. Heat cannot be stored in a body. Heat cannot be stored in a body as heat itself. As heat itself can only stored in form of, can only stored in the form of, can only stored in the form of particle vibration. Okay, now write this in a new line with double star, with a double star, with a double star. Now write this. Now write this. Double star. The vice versa is true. Can anybody tell me what is the vice versa? What is the vice versa? In my teaching technique, I normally let you to think because my teaching is all about giving you the conceptions. Concept. If you don't have the basic concept, basic reasoning in your head, you won't be able to write the answers in the exam. So mostly teachers do what? They teach very lightweighted way and students don't feel the weight, but in the exam they feel the weight, but in the class they don't feel because they think, he explained everything, he just do it, and you don't have anything to worry about. Yeah, your brain is getting filled with his ability, not your ability. You don't ever develop your own ability. Actually, we have to complete what? Your own thinking capacity to increase a lot covered in your brain. Okay, now just let me know what is the vice versa. Tell me. I told you the vice versa is also true. Can you just imagine what is vice versa only taking 1 minute? විනාඩියක් අරගෙන හිතලා බලන්න. Just take just like a 1 minute and think and let me know. Vice versa. My God, I feel like I'm actually teaching 2 grade 5 students in a scholarship exam. නිකන් නිකමට හිතලා කියන්නකො ළමයි මොකක්ද vice versa කියලා. Just imagine and let me know. Your answer might be wrong. It doesn't matter. Kinetic energy වැඩි කරද්දි temperature එක වැඩි වෙනවා. Somebody. Yes. Your answer is exactly dead right. He said when the kinetic energy increase, the temperature also increases. Yes, he understood. That boy understood. Really good. That's the understanding. Okay, right. Write this as the vice versa. When kinetic energy of particles increased by any mean, the temperature of an object raised as it gaining heat energy, as it generating heat energy inside. Okay. Let me explain you that. I told you about water molecules. Water. And let me reproduce this water molecule. It's too big. Okay, hundreds of water molecules in different orientations. Let me rotate. I told you, I can do like many magic here. This board. But physical board. So these water molecules may vibrate like this. These water molecules may vibrate like this. All the water molecules. So there is a natural vibration. As I told you, there is a specific radiation. What is that radiation? This radiation is known as microwave. The mobile phone as well as microwave oven uses this wave. It's something like a radio wave. As the microwave is being absorbed into these molecules, what is going to happen to these molecules now? These molecules will begin to vibrate faster. What would happen to these water molecules? Now the vibration increase. Oscillation increases. Okay, the oscillation increases, right? As the oscillation increases, what would happen to there? What would just happen to there? Temperature raise. Temperature begins to raise. Begins to raise. Copy this one really quickly. Within 1 minute. Just copy it within 1 minute. Okay. Now write very important topic, extremely important topic that is known as thermal equilibrium. Thermal equilibrium. That's why I took extra time to explain you what is temperature and what are the behaviors of temperature. Right. There are two objects here. One is A, the other one is B. These are thermally in contact. Thermally in contact means what? They might be physically in contact as well, or might not be physically in contact, but somehow thermally in contact means any of these three ways like what? Convection, conduction, or radiation, no, all three together. So somehow thermally well contact, that means this one can easily transfer energy to the other, right? In the thermal equilibrium condition, this one sends some energy to the other, but the other also sends the same amount. Imagine like transferring delta Q to the right hand side, same delta Q is going to transfer to the other side. So it is in balance. That means if you send 10 joules of heat energy to the B sends the same 10 joule to the A. So these two objects are supposed to be having what? Thermal equilibrium. That means the temperature of both the objects remaining at TA like here and TB here, and TA is equals to that of TB. Okay. Now write this in a new line. Thermal equilibrium. Copy this in your diagram. But before copying, write it. When two objects are thermally in contact, thermally in contact, and there is no thermally in contact, thermally in contact, and there is no net transfer of energy. There is no net transfer of energy between them. There is no net transfer of energy between them. It's said to be in thermal equilibrium. Net transfer. What is that net transfer? Net transfer means if you provide 10 joules to this side, the other one provides what? 6 joule to the other side. What happened? Now there is a net transfer 4 joule to the right hand side. This is not in thermal equilibrium, but this condition, it is thermal equilibrium because net energy is what? 0. Net transfer is 0. But there is a net transfer. What is it? 4. This is not thermal equilibrium. This condition is thermal equilibrium. Understand? Okay, we have to know this one. After that, extremely important rule of physics. Without this rule, you can't do anything in thermometry. Without this one, you can't do anything in thermal equilibrium. Sorry, calorimetry. Now write zeroth law of thermodynamics. ලියා ගන්න time දුන්නේ නෑනේ. Copy this one. Zeroth law of thermodynamics. Zeroth law of thermodynamics. මේක අඳගෙන ඉවර කරන්න. Copy this one firstly. Zeroth law of thermodynamics. What is that zeroth law of thermodynamics? Thermodynamic. Very important law, even though it laws as zeroth law, but it's really important. So go to the page here and read and come back quickly. This page is the page number 2. Really quickly go to the page number 2 and read and look at this diagram and come back. Come back means not to leave the meeting and read, just stay in the meeting and read and just quickly come, because it's really important to understand this one. Hello, Dinanga. Are you there?
Yes. Yeah.
What? Can't hear.
Yeah.
What did you say?
No, I am here.
You are here.
Yeah.
You are speaking with nose block or something. No?
Kind of.
I know. Okay. The girl has a really great courage than the boys. Boys don't speak, but the girl speaks. Okay. Quickly finish reading. Okay. Did you finish reading? Now write it. Now write the definition. If two bodies are thermal equilibrium with, if two bodies are in thermal equilibrium, two bodies are in thermal equilibrium with a third body, then they are in thermal. If two bodies are in thermal equilibrium with a third body, right, then they are in thermal equilibrium with each other. A good example is when there is a body which is A in thermal equilibrium with another body of C, and both of A and B are in thermal equilibrium with another. A and C are thermal equilibrium with another body B. So what would happen to this one now? A and B are well thermally equilibrium with each other. A sends and B resend back, and C sends energy to B and B resend the same amount of energy to C, and B sends some energy to A and A sends the same amount of energy back to here. So if A and B are thermally equilibrium with C, A is in thermal equilibrium with C, B is in thermal equilibrium with C as well. So that means A and B also in thermal equilibrium as well, right? In thermal equilibrium as well. That is what it says. Good example is when you keep A in touch with C, and now have a good look at this one is in touch with B. Very weird combination, no? A is directly in touch with C. Okay. And C is directly in touch with B. But even though these two are not touched, still in equilibrium. Even though these are not touched, still in equilibrium. Still in equilibrium. Copy these two diagrams. Copy these two diagrams. Okay, right. Now we have talked all about temperature. In the next one, it is all about thermometric properties. We have to go for thermometric properties. After that, thermometric properties and temperature. Now write this in a new line. Thermometric properties. Thermometric properties. Big topic, thermometric properties. Metric properties. Let's do all the thermometric properties and take a short interval and come back and do all the thermometer questions and the theory. Okay, now right. Now I'm going to accelerate because I have taught the very basic, taking a long time. These are really easy because when you know the very basics. Okay. What are the thermometric properties? Firstly, right. Temperature is a sensation. Temperature is a sensation to the human skin. The human skin. But how to measure? But how to measure? In a proper way. In a proper way. See, some ideal properties, it should increase or decrease in this type of way. And there are many ways to express, but I will teach you each in this class. I didn't include all this data in the tute itself. Okay. Now, right, to measure temperature exactly, it needs to measure temperature exactly. What is that? To measure temperature exactly. To measure temperature exactly. I know that Sajan might be asking what happened to you. He's a really flirty man. To measure temperature exactly, how to go for some certain thermometric properties. Thermometric properties. Write this in a new line. The thermometric properties should be with some specific, measurable and clear properties. Number one. So no, before write for number one thingy, we have to go for another important point. Write this thing with the double star. There are some certain physical properties. Which changes over with external temperature. Which changes over with external temperature change. with external temperature change. Shall I tell you one example? As I mentioned, expansion. Okay. This is what the original length. Now you may increase temperature, it will extend to here. If you decrease temperature, it will shrink to this much. So these are physical properties. There are some other physical properties like change of resistance, change of what is it called, potential difference, change of volume. In a simple example, a balloon. When you keep a balloon, inflated the balloon in outside, but you keep it in deep heavy sunlight, what happens? You have that experience, the balloon explodes. Why? It will expand and expand and expand and reach to some maximum level and can't tolerate and explode. And when you get it to a fully AC room, it shrink. Why? Because the volume decrease. This is also a certain property we use to see in our day-to-day life. And there are some other properties as well. What are the other properties? Like change of color. There are some other chemicals and the stuff behave in different, so some different color. There are many properties, but we can't take all the properties in count. There are many reasons. I will teach you what are these specific reasons. Now write all the physical properties which may change, according to temperature, can't count on. අපිට හැම එකක්ම ගන්න බෑ. Why? There should be some specific properties. Property number 1. What is the property number 1? Right? The thermometric property. Number 1, the thermometric property should be a continuous but continuous variation with temperature. With continuous variation with what? Temperature as a continuous function. Example, it should raise with rise of temperature and should reduce with drop of temperature. It should reduce with drop of temperature. Okay. Now write the function. The function should be what? Omni-resultant function of temperature. What is that omni-resultant? Huh? What is that omni-resultant? That means the property that we are talking about should be only varying with temperature only, not with any other. Right? It shouldn't vary with any other physical parameter. only with the temperature. Okay. Imagine volume. Volume. As I said in the earlier case, volume of this gas inside the balloon. Volume. The volume increases with temperature. Yes, we know. As you increase temperature, the volume increases. Okay. But that is not the only factor. If you reduce the external pressure, this one also going to increase. With the pressure as well, it varies. So if the pressure also varied, what happened? We can't measure the temperature because it is no longer omnidirectional. It is not only varying according to the temperature. ඒ කියන්නේ මේක කීයටවත් temperature එක විතරක්ම නෙමෙයි වැඩේ වෙලා තියෙන්නේ. ඒ කියන්නේ හරියට having a cross connection. මට නුඹ විතරක් වුණාට නුඹට ඉන්නේ මම විතරද කියලා සින්දුවකුත් තියෙනවා. Like that. So it is not responsive only for the temperature. It is not going to apply. Can you understand? It should be okay. And the third one, the change of physical property should be the very best part comes. Very best part. Okay. Have a good look at here. It should be a linear one, like this, like this, like this, or sorry, linear. It should be a linear relationship. A drop. A drop. Drop is acceptable as well. See, the property versus temperature. Property versus temperature. Even the it drops, it doesn't matter. If it raise, it doesn't matter. It should be a linear property. That means imagine for 5 Celsius, it only shows 5x, right? From 5 Celsius to 10 Celsius, if it shows like what? 20x, is that in a proper range? No. So you can't use this type of properties, like varying like this, or varying like this. No, it is not uniform. Why? In this part, have a good look at, I will explain this thing. Have a good look at. Now for two different conditions in the, like in two different lengths in extension, you read the same temperature. It's wrong. Here you may get what? The same temperature, sorry, same physical property for different same length. It's like throwing a ball. See, the same height, but two different time, T1 and T2. You know that the T2 is greater. Two different time scales, but it is in the same height, like that. So see, the temperature is T1 here, temperature is T2 here, but you measure what? Same delta exchange of the physical property. So you can't use these type of variations. You are only allowed to use a permanent and fixed and a straight uniform change are the next thing. Now write the thermometric property. The thermometric property should be with high sensitivity. What is the sensitivity means? Just say that you and your friends were together, right? When one guy leaves you and saying bye machang mama yanama, Then you get a news that the guy met with an accident somehow. He met with an accident somehow. The other guy picked the phone and say, "Hey, Mashang, aru happilane Mashang mara vade." He's so sweet. His face is like dreadful, and his face has some. He's just about to cry, and the other friend who listened to that and he began to cry and just again bima vatila perli perli andano. And now it's you. You hear the happy lada macha. Hoyole danne ani. That's your response. Now see the three difference in the response. The first guy is about to cry. The second guy is crying and you can't stop. And the third guy, you, insensitive dude. But you say, happy lada. That's what. Now can you see the sensitivity? It's the same phenomena. What? Your friend's accident. But three different responses. For a certain physical change, if the response is really high, has a really high accuracy. Imagine like for a delta T temperature change, a certain metal shows some length change of delta L1. There is another metal, but the length change is really low, delta L2. So which one is more sensitive now? A or B? අඩුම ගානේ මට මේකටවත් කියන්න which one is more sensitive? Which one is more sensitive in this device now? Can you tell me which one is more sensitive in this device? Which one is more sensitive, A or B? Device A or device B? I told you something like sensitivity. Which one has the highest sensitivity? The device A or the device B? Guys, I need to know. Sensitivity. What is the meaning of sensitivity? Response for certain change of physical factor. Yeah, good. It is the device A. Device A has a really high sensitivity. Sensitivity is nothing other than change of delta X, the physical parameter, over temperature of delta T. When you change the temperature by a certain factor of delta T, if the change of delta X is really big, the device has a really high sensitivity of temperature. Because we know something called what? Zero errors. The fractional error of delta X over X, you have to know. If when you convert it to percentage error, if the percentage error is more than 1%, it is no longer going to get acceptable. Why? So that is why we have to go for a device with really high sensitivity. That's the third factor. Sorry, that's the fourth factor. And the number 5, factor number 5, write it. The amount of absorption of heat. Number 5, the amount of absorption of heat. The amount of absorption of heat energy should be really low. The amount of absorption of energy should be really low. So that means if the device absorbs really high amount of temperature to show the detail, it is actually going to make some loss. It's going to make some big loss. It's going to make some big loss in the temperature. So it is not going to get acceptable in this manner. So we have to use something with what? Low temperature efficiency. Okay, the next one. Next property is, last property. It should show quick results. Okay, if you are going to measure the temperature of a certain flame and the flame is only about to last 5 minutes, the flame is only about to last 5 minutes, but if the thermometer takes like 30 minutes to give the reading, can you read that again? Ever? No. If this gives the reading with like 5 seconds, 10 seconds, it is a really good device. But if it takes, say, 30 minutes, it is not going to acceptable. Can you understand it? Okay. So we talked about it, and I hope you drew these diagrams. If you didn't draw this, these ones are acceptable values. This one and this one. These type of properties are not going to count. Quickly copy this. Quickly copy this one. Oh shit. The common thermometric properties, right? This one has common thermometric properties. Common thermometric properties. And these 5. After that, we have to go forward. the structure of thermometer and the kind of thermometric scales like Celsius scale, Fahrenheit scale, and how to convert one scale to another. One scale to another. Okay, write these 5 factors quickly. Okay, I'll give you a very short interval of 15 minutes. Right, very short interval of 15 minutes. And join back after exactly 15 minutes. Now your timer starts. And I will teach you the thermometer and the build of the thermometer. Stay in the meeting, mute your device, and take 15-minute interval. Join exactly around 11:20. 11:20 starting time. Hello guys, are you there? Now your short interval is over.
Yes.
Are you there?
Yes.
Okay. So your short interval is over. We have to deal with what? Thermometric properties we learned, and today I'm going to teach you the basics of what? Thermometers. Not this one. Wait. So, oh, what the heck is this? Heat and thermometry. So here, just there are certain things like low fixed point, right? Steam and the triple point, and something else. So actually today we have to deal with these ones to learn and the temperature parameters and the change of temperature and the scale and Celsius and Fahrenheit scale and Kelvin scale all. But I think we might not have enough time to do all of these. But I will basically teach you the lower fixed point, upper fixed point, and the fundamental interval, and at least one of these variability with the basic equation at least today. Okay. So as I promised, I am just going to show you the change of temperature and the what is it called, thermometric property thingy. But until, so will you just read this part, not this one, the thermocouple thing, because I am going to show you this part. How a thermocouple shows the voltage change and the stuff you to get a certain proper idea. So read the page number 7 and 8. Page number 7 and 8. Okay. Until I set up that thing, until me to set up that, just read. Okay, take it 2 or 3 minutes.
Okay, Lamai, can you hear me? Just confirm me whether you can hear. I taught you to read that thing called what? The thermocouple thingy. So there is a what? This is a multimeter. In the multimeter, we can change slight variation of voltage. I just put it to some 20 volt range and fix with the something called Peltier cooler device. But this one is completely worked under the theory of what is it called? Thermocouple. Thermocouple means certain metallic devices inside there. So as I just change the temperature, this one will show you the readings on it. So let me drop this one for a while. Okay. So let me hold this. It's covered, but I will show you the temperature. So can you see the reading? Can you see? Now it drops. Now it drops. Why? Now it's getting cooled. Now it's getting cooled. Within a time, it will turn back to 0 again. It is 0 again. Right. Okay, let me hold it like this and show you. You will see the trace of temperature. See, actually the voltage 0.3 something, 0. What see? It increase. Now see, can you see the thing increase with the voltage increase with what? Temperature. As I hold it furthermore, now it's even higher, even higher. Now I remove this effect. Now you will see it will drop and drop and drop and drop and drop. 0.7, 0.6, 0.2, 0.4 again, 0.3, 5, varying, 0.1, and finally 0. I can do the same magic using what? If I held an ice in the opposite side, I held this lighter to this surface. If I held an ice in this surface, the same effect may affect in this one. Now you can see there is a change of what? Certain physical property. What is that physical property I used here? The physical property I used here is temperature as the varying factor using this lighter, and this is a thermocouple. In this thermocouple, it produces relevant what? Relevant voltage difference. So we can just get the difference of voltage and demarcate it on the scale as what? Temperature. This is calibrated in volts. If I just change the there's a software inside this. If I just change the software, instead of volt, if I just mark it in temperature, it will show up the relevant temperature. Can you just understand the concept that I'm teaching about here? Okay, guys, if you understood this one, let's go back to the thermometers, and I will firstly start to teach you like the basic thermometer properties, and those theories I'm going to teach in the next week, because actually it should taught today and go to that, but you won't be having any calculations to do. Then it's going to be really boring for the entire day, because we didn't have any calculations so far. The next lesson is full of calculations. You will find really overwhelmed with the calculations with the expansion lesson, because the volume expansion is the really hard calculations you make it. But for this lesson, only one type of calculation you get. It's what? Conversions. Let me teach you the firstly the scale, and do one calculation at least today and end the meeting. Okay. Okay, it's turned off. Shall we go back to the same virtual board again? Okay, in the virtual board, I will show you the thermometer scales, how to scale, and just make a scale use of some other property. In regular thermometer, what is the regular thermometer? The mercury thermometer, you have only one property, what? Varying length from small length, bigger length. The varying length, but we have marked what? Scale in temperature. I will teach you how to change. Shall we move? Okay.
Okay, guys, welcome back to the board.
It is not a cooling sink, man. It is called actually cooling device, Peltier cooler. We call it Peltier cooler. We used in computer science to cool down those processors and the stuff. Right? We use this to cool down processors. It completely worked under the concept what? Thermocouple. This thermocouple principle is the principle it works under there. That's why I asked you to read this page. The junction thingy, I will explain this all in another day. As I promised, I just need to teach you how to make this calculation thingy. Write this. Write this as a subtopic. Principle of what? Thermometers and thermometer scales. Principles of thermometers and thermometer scales. Write that. Principle of thermometers. The principle of thermometers and what? Principle of thermometers and thermometer scale. Thermometer scales or temperature scales. We call them as temperature scales. මේකෙන් තමයි ගානක් එනවා නම් එන්නේ. This is where you may find the calculation in a test. In such a test. Okay. What is it going to be? Let's see. Now again, come back to these readings. There are fixed points. See, one is ice point or the freezing point, steam point, that is called the boiling point, and a triple point. There are 3 points that we have to consider about. Now write all the thermometers are made according to all the thermometers are made according to a certain fixed scale. A certain fixed scale. Certain fixed scale according to its own variabilities. Write this in a new line, but in a convention, there are 3 basic points to be concerned. There are 3 basic points to be concerned. Number 1, write it freezing point, not ice point. Write it freezing point. මොකද මේ බලන්න තේරුම් ගන්න. Ice point, freezing point. Freezing point of water. Actually, write it freezing point of water. Right. Now write the definition. The temperature when pure water, ice, is in equilibrium with liquid water at standard atmospheric pressure. Quickly write that.
So that means in this point, this ice and the liquid both are in an equilibrium at this point. Because if it turns 50 grams to liquid, 50 gram becomes ice. So this is in an equilibrium under 0°C. So this temperature is the thing not as X naught. In Celsius scale, what is it? 0°C. In other knots, it is the X of that, and we call it like X naught. So copy this diagram quickly under that. Copy this diagram quickly under that. Now write boiling point quickly. Boiling point. Write it. The temperature when pure liquid exists in equilibrium, pure liquid water exists in equilibrium with water vapor at standard atmospheric pressure. Atmospheric pressure. So normally liquid and the steam in an equilibrium. That means 5 gram become steam. Meanwhile, 5 gram become liquid. This is what in equilibrium. Normally for water, we call it like what? For normally for other devices, we talk it like XL higher limit. You will learn what is this higher limit. And for Celsius scale, we take it like what? Celsius scale, it is normally like 100 degree Celsius. Quickly copy this one. And write the last one. Triple point. Triple point. Triple point. Write this one in a new line. Temperature when pure water ice, pure water liquid, and pure water vapor exist in an equilibrium. Write this in a new line. In practical aspects, triple star point. In practical aspects, the difference between boiling point, melting point, freezing point, freezing point and what? Triple point is about 0.01 degree Kelvin. 0.01 degree Kelvin. So it's mostly negligible. So it's mostly negligible. So actually I'll have to teach you something about this anomalous expansion of water. The anomalous expansion of water. But today, if I'm going to teach you that part, you will not be able to do that calculation thingy. So I will teach you the anomalous expansion of water thingy in the next week. So that's why we can't use water as a what? The volume. It is all due to something called hydrogen bonding in water. You might know what is hydrogen bonding if you do chemistry. At 4 degrees Celsius, this has the lowest volume. In terms of density, highest density. The nature or the certain God who is really genius, who made this world, who survive what aquatic plants and aquatic animals. Otherwise, if there was no such what anomalous expansion in water, no aquatic animal would survive in those freezing countries and freezing areas. Because why? The water becomes frozen on the top, and there is the liquid water at 4 degrees Celsius at any condition. So these aquatic fishes and other ones can survive there. I will explain this phenomena in the next week in detail, right? Someone who created this world is a really genius, who had concern about all these points. Okay, now right, we learned about the very basics. Now right, in this one, for a certain temperature scale, 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 it needs something called lower fixed point and an upper fixed point. Lower fixed point and an upper fixed point to build up the temperature scale. To build up the temperature scale, that is called the fundamental interval. Okay, copy this one, copy this diagram. Copy this diagram. Now write subtopic like lower fixed point, lower fixed point. Lower fixed point. The change of physical property, now write this on a new line. The change of physical property, under some standard physical condition at decided specific lower temperature with the noticeable varying physical condition. Okay. Now write this in a new line with the definition. Mostly the lower fixed point is taken as freezing point of pure water under standard pressure, standard atmospheric pressure. Now write this in a new line with the double star point. This is taken as the 0 degree Celsius, 0 degree Celsius in what? 0 degree Celsius in Celsius scale. And now write this in a new line. Upper fixed point. Upper fixed point Write this. Upper fixed point. Write this. The change of temperature at specific change of physical property occur. Write with the definition form. The boiling point of pure water is taken as upper fixed point of so many measuring in thermometer scales, temperature scales. I write this in a new line with double star point. In the Celsius scale, that is marked as 100 degree Celsius. This is how you make certain what the scale. Now have a really good look at. As I told you, when you keep a thermometer scale, here at lower fixed point, We call it like 0 degree Celsius. This is called the higher fixed point. That's called, we marked as 100 degree Celsius. Right? So there is a gap between these two. And you can take it like length, volt, difference in volt, difference in volume, difference in something like color change, whatever the property in between, but we are just about to make a certain proper scaling, how to make this scale, right? How to make this scale. So we have a fundamental interval that's called Fi, fundamental interval. So you can divide this fundamental interval by 100 and you may get the scale. When you divide it by 100 such divisions, I will mark it like, I can't actually mark 100 divisions, but I'll mark like equal some 10 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in the same way, okay, මේ කියන්නේ මේක කඩලා මම අවශ්‍ය දැනට ගත්තා කියන එක. You may get what? 0 here, 10 here, like that, 100. You can mark this into this type of scale. Can you understand how did you just form this scale in Celsius scale? In the Celsius scale, I can mark what with a regular thermometer with 0 to 100. But the same way, I can interpret any other form. According to your own name, you can make a certain temperature scale. Who are there? Devtirina. Devtirina, you can make your own temperature scale using some fixed variable. You have to find out certain fixed variability and make some on scale and mark it like that Celsius. That means he's a scientist also. Fahrenheit, Daniel Fahrenheit and Lord Kelvin, like that they make their own scales like that. Devtirina, you can make it like Dev scale and Jaufer scale. For me, Tarindu scale. Like that. I can make certain scale according to some certain physical property change. Right. Can you basically understand this concept now? Always we have to compare normally with Celsius scale and any other X. Normally, this is what our variation. With one variability with another. Normal variation is from Celsius to any other. Right? Normally, we can also compare Fahrenheit to Kelvin or anything to anything. But our regular customer is what? Celsius to anything else. Okay, Celsius to anything else. That's why our regular customer with the known temperature, and we can compare that to get any unknown temperature change. Okay, now write all the temperature scales are work according to all the temperature scales are work according to all the temperature scales are work according to certain fixed scale. So one scale can be compared with another scale. I will explain you this in detail in the next week. But for today, just rapidly, I will give you this. But this is a really rapid notation. Don't worry, in the next week, I will give all these in detail. Okay. As I told you, this is filled with what? Mercury or alcohol, normal thermometer. It might show you it up to some height for some temperature. We don't know, right? I'll mark this one like at the beginning x0 or x1, whatever. At this level, I'll mark it like x, and I'll mark this like x2, and I'll mark it like x1 and x2. That's easier, right? I'm going to extend few lines from this line, from here and here, and from this 0 line, lower line. So dot line. Okay, this is really important. Now I am going to mark the Celsius scale here. Our most familiar one, Celsius scale. Now going to mark Fahrenheit scale. Now going to mark what? Kelvin scale. So as you know, I told you in the Celsius scale, the lower fixed point for Celsius is, this is the Celsius scale, Celsius, and this is what? Fahrenheit and Kelvin. Lower fixed point of here is what? 0 degree Celsius. And here, what is the lower fixed point? 32 Fahrenheit. It is really uncommon one. And for the Kelvin, what is it? Minus 273. 0.16 is also there, but we don't want to consider that. I will also mark Kelvin. What is the highest fixed point here? That is 100 degrees Celsius. That is what? 212 degrees Celsius Fahrenheit. And this one is what? 373.16 Kelvin. So there might be certain temperature of certain what? Theta Celsius, theta Fahrenheit, and theta Kelvin. That we don't know. That we don't know. So how many equal parts are there? How many equal parts? 100 equal parts. Equal divisions. How many equal divisions are there? Now subtract this one, the 212 subtracted by 32. You will have 180 equal divisions. 180 equal divisions. How many? You will see some phenomenal thingy here. It is also 100 equal divisions. That means these two are just two names, but the same scale. Just two names, but the same scale. That means 10 degree difference in Celsius is exactly as same as of the 10 degree difference in Kelvin as well. Can you understand? 10 degree difference in Celsius is as same as of 10 degree difference in Kelvin too. Okay. So you will take a long time to copy this diagram. So take a screenshot, please, and keep some space in your book and write later. I'll have to form the equation and show you one calculation for today and stop the class. නිකන් අද ආපු එක නිකන් වැඩක් නෑ වගේනේ මේකෙන් ගාණක් හදන්න නැතුව ගියොත්. That's why. Okay, take a screenshot and I'll send you this PDF even to the group, but I don't know these guys are from what group and what group. I have no idea. Otherwise, I can share you the board drawings as a PDF.
But how can I say? Since I don't know who you are, where are you from? I don't care who you are. Theta here, any theta change. This axis, any x. So whatever it is, if you just draw a graph, it is something across what? Graph across what? If you graph these properties across origin. So I'm going to consider one point here in the x-axis. I take it like this one is like what? X1, and the corresponding reading here, it is known as, I'm going to take it as theta 1. Okay. Any other point? Any other point? I'm going to take this one as what? Theta 2. And the middle point like theta. And here just x and x2. When I write the ratio of these ones together, what is the full scale expansion here? What is the thing I want? I want this delta x and delta theta. Okay. So I'm going to take the ratio of delta x over delta theta. What is my delta x? X over x minus x1 over, what is this delta theta? Theta minus theta 1. Okay. That is what my thing I want, but is the full scale should also have the same ratio. What is my full scale is going to be? X2 minus x1 over theta 2 minus, theta 2 minus theta 1. You can apply this equation to any of these temperature scale conversions from whatever to whatever, from Celsius to Fahrenheit, Celsius to what is called resistance, temperature, Celsius to some kind of voltage change, Celsius to volume change, whatever, right? You can convert using this simple equation. Okay. Very simple equation. Now, if it is Celsius, if Celsius as theta, theta කියන්නේ කවුරුත් නෙමෙයි Celsius. Now, what is it going to be? X is x, x1 is something x1, but here, what is theta? Theta is theta, I don't know, but theta naught is 0 degrees Celsius. What is x2? X2 is 100 degrees Celsius minus 0 degrees Celsius, and theta, sorry, I made a big mistake. That's x thing, you know. That's x2, I don't know. X1 something, but theta 2 is 100 minus 0 degrees Celsius. Now I can rechange because I can just cut this out. I want to find out what theta in Celsius according to some value of x. What is the equivalence of x in terms of theta? Theta in terms of x. How? Theta is equals to x minus x1 over x2 minus x1 times 100. Using this conversion, you can find out theta. Copy this.
This is what the mathematical approach. Let's do just one calculation and end the class for today. Copy this entire diagram, this one. Until you to copy, I'll get a question from this one. I'll give you like 30 seconds more to copy this. I think I gave you enough time. I'll give you another 10 seconds. 10, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. And enough. Let's do this now. It says some thermometric property given its value as 5 and 20 in the relevant units temperature in 0 and 100. Okay. This is the first one. I will draw. Otherwise, it doesn't need. This is the unit. We don't know anything. It can be 5. Here, what is it? 20, the maximum. But in Celsius scale, 0 degree Celsius. And what is it? 100 degree Celsius. And you measure certain value. In here, it reads as 11.0. But there is a certain theta in Celsius there. Theta Celsius, but we don't know. Now we have to convert and find out that temperature in terms of Celsius. Once you found, we can convert to Kelvin. You know this since grade 6, 6th grade. I will teach that one also in the next week. But for today, for very simple, what is the ratio thingy again? X minus x1 over theta minus theta 1 equals to x2 minus x1 over theta 2 minus theta 1. Let me substitute all. What is my x? It is 11. What is my x naught? 5. What is my theta? I don't know. What is my theta 1? 0. What is my x2? 100 degrees Celsius. What is my x1? 0 degrees Celsius. What is my theta 2? Here. Oh, sit. That's x. Okay, that's x. Always I forget. That's x2. That means 20. What is x1? 5. What is my theta 2? 100. What is my theta 1? 0 degrees Celsius. 0 is no value. Then I can forget about it. In the top, I get like 6. This one is theta. In here, I'll get 15. And here is 100. Now what I want to get is theta theta equals to 100 over 15 multiplied by 6. Okay, how many fives are there? 3. How many fives are there? How many fives? 25s. How many threes there? 1, 3, and 2. What is the degree in Celsius for theta? Equals to 40 degree Celsius. Can you understand the process how I obtain this answer, arrive at this answer? තේරුණා ළමයි මම ආන්සර් ගත්ත විදිය?
No, sir.
Others? Okay, take a screenshot of this one and leave the class for today because I have another seminar within 13 minutes from here. I have no interval. That's how teachers are. So take a screenshot and let's end up the class for today. God bless you guys.
God bless you, sir.
God bless you. Bye. Class is over.